Hello, in this video, I will be demonstrating my project called User-Oriented Parking Garage Control and Communication System. To start off, the user is in the planning phase of the parking process and must find a parking lot with available spots. Therefore, they go to the parking lot's website and can see if the lot has open spots. After the user finds a parking lot, they can use the Wi-Fi connected camera to see the parking spot's dimensions to ensure that their vehicle will fit and the spot is not partially blocked. The user now has arrived at the parking lot. They must now enter through the traffic control gate. As they approach the gate, the infrared sensors detect the car and check the count value of the counter programmed into the system's Arduino board. The user is let through because the gate's programmed counter's value is less than the number of parking spots being sensed by the ultrasonic sensor. The user now enters the parking lot and checks the entrance LCD, which tells them exactly which spot is open and how many total spots are available. The user now travels to the open parking spot while not experiencing any traffic. The user parks their car, which is then detected by the ultrasonic sensor. The ultrasonic sensor sends a signal to the connected Arduino board, which then updates the number of open spots on the entrance LCD. The Arduino also sends the data from the ultrasonic sensor to the Wi-Fi module, which then updates the amount of open parking spots on the website. The parking process is then repeated for 2 more cars, as we are only detecting 3 spots in total. Each time a car enters, the programmed counter in the traffic congestion control system increases until the value of 3. Also, each time a car parks, the entrance LCD and website is updated by the data outputted by the ultrasonic sensors. Having the entrance LCD displaying which parking spot is open allowed the user to travel directly to the spot instead of roaming around the parking lot, saving the user time, money in the form of gas, and reducing CO2 emissions into the atmosphere. Every time the website updates its number of open spots, this saves other users time by allowing them to know if there are available parking spaces before actually traveling to the parking lot, as well as saving them the stress of having to roam the parking area looking for a spot. It is important to note that this process can be scaled to fit any number of parking spots as long as the parking spots' availability are being detected by an ultrasonic sensor and the program in the traffic control system is set to the right amount. Now that all the parking spots are occupied, let's see what happens if a 4th user tries to enter the parking lot. The user is not let into the parking lot. This is because the counter programmed into the traffic congestion control Arduino is at its max count value. Therefore, a message saying the lot is full is displayed on the gate LCD. This is done to prevent traffic in the parking area, allowing the user to more easily maneuver the parking area. The cars are able to leave the parking lot by approaching the gate. As they approach the gate, the IR sensor senses the user and activates the servo motor opening the gate. At the same time, the programmed counter in the traffic congestion control system decreases by 1. The entrance LCD and website are also updated as the ultrasonic sensor is now sensing no object in one of the spots. This process continues until all the spots being detected by the ultrasonic sensors are unoccupied, and thus displaying the max value of open spots on the website. This also means that the counter programmed into the traffic congestion control system will also be at its max value.